Alright, let's try something a little bit different. Steadicam mode. Okay. The reason I'm doing this is because I don't have enough hands to do it all. Okay, so we're just going to do the test going around the batteries, and you'll have to take my word for where I'm positioning the probe, because I don't have enough hands to show everything. Alright, so right now the system is on. Oscillating, and what I'm going to do is first I'm going to touch the probe. Oh yeah, this is the zero baseline. We're at 10 volts per division, and the battery voltage right now is showing 47.3 volts, and so that would be, let's see, 10, 20, 30, 40, 7.3 volts would be just below that gradical marker right there. Okay, now I'm going to touch the probe to the common MOSFET drains. Okay, so there you see the Buku oscillations. We're at 1 microsecond per division on the time base this way. Oh no, I'm sorry, we're at 0.5 microseconds. That's 1 microsecond. And so the oscillation frequency then is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cycles in 8 microseconds, which is 2 megahertz. Okay, and it's just a hair over the 8th position there. So that means slightly less than 16, so slightly under, it's just barely under 2 megahertz is the oscillation frequency right now. Okay, so let's go up here and display it a little bit better. Alright, so remember the battery voltage is 47.3. We're at the common MOSFET drains. So here's 0, 10, 20, 30, 40, 7.3. So we've got oscillations going positive and negative. I mean, not positive and negative, but plus and minus the battery voltage somewhat. But it doesn't come anywhere near going negative down here, right? Okay, so now I'm going to move the probe to the positive rail at the board. This is where the battery connects to the board through the battery cables. Okay, there you go. So now we see the amplitude of the oscillations is certainly decreased there. But we still see that same characteristic shape of the oscillations on the battery. This would be called the battery trace. This is what the nerds use as what they call the battery trace. Oh, the ground reference lead is clipped right to the most negative pole of the negative battery. Okay, now I'm going to move to the most positive pole of the main battery stack, right there. Okay, so now let's look at the amplitude of those oscillations with the caliper. All right, so I'm going to measure from peak to peak, and then go down here to the scale, and I see 1.7, call it 1.8. Times 10 volts, so that's 18 volts peak to peak on those oscillations there. Okay, now I'm going to move down one battery. This is to the 36 volt positive pole right there. Let's reestablish trigger. All right, like that. Okay, so now we're at 10, 20, 36. And the oscillations are symmetrical around that 36 point, or not symmetric, but at least they're going back and forth around that 36 point. And the amplitude of the oscillations is now 1.4 divisions at 10 volts per division, so it's 14 volts now, peak to peak. Okay, now I'm going to go to one more battery down. There. That's the 24 volt positive. 10, 24, cutting right across the middle of those oscillations again. Alright, and the peak-to-peak amplitude of those oscillations is 8 volts, 8/10 of a major division, so that's 8 volts. Okay, now we'll go down one more to the positive pole of the least positive battery in the stack, the negative battery. And you can see the voltage there, but the oscillations are not big enough for me to get a trigger, so I'm going to change the amplification to 5 volts per division instead of 10. Let's see if we get a good trigger there. Okay, 5 volts per division now, and so there we're at 5, 10, 12, right? And the magnitude of those oscillations, the amplitude, peak-to-peak amplitude, is now 6/10 of a major division at 5 volts per division, so that's 3 volts, right? Yeah, 3 volts, okay? That's the peak-to-peak amplitude now of those oscillations. Okay, and going back up, let's see, I'll just go. I should have done this by going from wire to wire, right? Okay, so now what I'm going to do is do the same thing, except I'm going to go to the jumpers first. So here's the, here's the positive pole of the positive battery. Here's the negative pole of that battery. And there's oscillations like that of 18 volts. Now I'm going to go just to the other side of the jumper. This will be to the, now I'm on the negative pole of the most positive battery. Now I'm going to go to the positive pole of the next most negative battery, and that's separated by about 3 inches of wire. So that's that right there. And you can see that the magnitude of the oscillations has actually decreased just from that 3 inches of wire. So now we're down to 15 volts on the amplitude. Now I'm going to go to the negative pole of that battery, right there, and so now we're at just about 11 volts. Now I'm going to go to the other side of that jumper, another 4 inches of wire, right there. That made a big difference. See, the voltage level from here to here doesn't really change, but the amplitude of the oscillations changes, right? This is just on the other side of 4 inches of wire. Now I'm going to go to the negative pole of that battery, there, and let's go ahead and switch the time base now. Okay, so at half a volt, or rather 5 volts per division now, we have an amplitude of 1 full division, which is 5 volts. Okay, now I'm going to go to the other side of that jumper, right? Boom. That's another 5 or 6 inches of wire and a couple of connectors. And once again, you can see that the voltage level itself didn't change, right? We're still jumping up and down around that same baseline of 12 volts, right? 5, 10, 12 volts, right? But just going from this end of that jumper to that end of that jumper made a huge difference in the magnitude of those oscillations, right? And we'll go back to here. This is the most positive pole of the battery, so now we're looking directly across the battery. Okay, thanks for watching.